Today's lecture will be on the units and prefixes used in measurement systems. The two most common systems of units of measurement are the U.S. customary system and the SI or International System of Units. The U.S. customary system is what you would use when you drive 35 miles per hour to the grocery store and buy a gallon of milk and 2 pounds of potatoes. The SI system is what we use primarily in engineering, and it's also much more common in Europe and worldwide. The four basic dimensions and the corresponding units in both systems are shown here: the length, mass, time, and force. The SI system was founded on 7 base units for 7 dimensions that are assumed to be mutually independent. So these 7 units here. And all other quantities, which are called derived dimensions, are defined in terms of these 7 base units. Here are some examples of derived units in the SI system. The first example is force. The unit for force in the SI system is a Newton, which is equivalent to a kilogram times a meter divided by a second squared. The corresponding unit in the U.S. customary system is the pound. Pressure is newtons per meter squared, or Pascal. Energy is joules. Power is watts. Speed is meters per second. And solid volume is meter cubed. Liquid volume is a little different. The unit for liquid volume is liter, and that is the unit in the metric system. Technically, the SI system doesn't have a unit for liquid volume, but we use the liter in the SI system. And in the U.S. customary system, the corresponding units for liquid volume would be a gallon or an ounce. In the SI system, prefixes are often used rather than writing out the engineering notation. A unit prefix is actually a symbol that goes in front of the basic unit to indicate a decade multiple or fraction of the unit. So, for example, instead of writing 5 times 10 to the third grams, I could write 5 kilograms. The K here is a prefix. It's actually the symbol that goes in front of the basic unit, which is the gram, and indicates a multiple of 3. And if you look here at this chart, the K here stands for a kilo, which represents 10 to the 3. So this 10 to the 3 right here can be replaced with a kilo, which is abbreviated with a K. Now, if you remember from engineering and scientific notation, 10 to the negative 1 is the same thing as 1 over 10 or 0.1, and that can be replaced with the prefix deci. The abbreviation is a small d. Or 10 to the negative 2 is 1 over 100, or 0.01, which is a centi. 10 to the negative 3 is 0.001, or milli, and so on. So 10 to the 3 is 1,000. So this is 5 times 1,000 grams, or 5 kilograms. Likewise, if I have, let's say, 6 times 10 to the negative 2 meters, and I want to replace this 10 to the negative 2 with an abbreviation, I go to my chart. Here's 10 to the negative 2, so I know I can replace that with a centi, and the abbreviation is a small c. So this can be written as 6 centimeters. And these two numbers are exactly the same. Or if I had 17 times 10 to the 6 grams, I could replace 10 to the 6 with a prefix. So I look at my chart, and here's 10 to the 6, so that's a mega, which is replaced with, or represented by, a capital M. So this could be rewritten as 17 megagrams. So you're essentially just replacing the power of 10 with a prefix that represents that power of 10. Now, one thing to note is that all the values above this line here are values that represent numbers less than 1. And the values below that line are values greater than 1. If the prefix represents a number greater than 1, like 10 to the 6, 10 to the 9, etc., typically that prefix is capitalized. The one exception is the kilo. And if the prefix represents a number that is less than 1, like 0.001 or 0.000001, the value is typically lowercase. There are some basic rules when you're using SI units. For example, symbols of units are not plural. You don't make them plural. You would put 5 millimeters. You do not add the S on the end. Symbols are not italicized. Oftentimes, for some reason, people like to italicize the symbols. That's not correct. Symbols are capitalized if the unit is named for a person. Otherwise, it should be lowercase. Put a space between the number and the symbol, except for the degree symbol for angle. So in other words, here we have 5 millimeters. There's a space here. But if I had 5 degrees, the degree would go right there, right after it, no space. But, for kilograms, you would put a space here between the number and the symbol. And spaces or commas between groups of digits of 3. So you could put 1 million as 1, a space, 3 zeros, another space, and 3, or you can use commas. Or you can put that in engineering notations. Symbols for derived units with multiple units are joined by a space or a center dot. So kilogram meter should be kilogram with a space meter, or kilogram and a dot in between meters. Okay, so you do not run them all together like this. I prefer to put the dot there, but you can do it how you want, except you don't run them together. And then you never combine prefixes. So a gigameter is 10 to the 9th. Well, kilo is 10 to the 3, and a mega is 10 to the 6. But you can't, these are not equal. This is not correct. You don't combine prefixes to try to make a bigger number. You just use the higher prefix. So let's look at a few examples. What you're asked to do here is to replace the engineering notation, so the power of 10 here, with a prefix. So essentially getting rid of 10 to the 3 and just having 362 with a prefix. So if you'd like, you could pause the video and try to do these on your own, and then we'll go over them. So in order to do this, I just need to replace the multiple of 10 with the symbol that represents that value. So in the first one, I have 10 to the 3rd. If I look on the chart, 10 to the 3rd is right here. It's a kilo. It could be represented by the symbol small k, so that can be written as 362 kilometers, keeping the same units as up here. 4.5 times 10 to the negative 3 grams. That 10 to the negative 3 can be replaced with a milli, which is the represented by small m, so 4.5 milligrams. The next one, 1.32, I can replace 10 to the 6. Look on my chart, it's right here. The value can be replaced with a mega, so mega liters. Number 4, 54. This 10 to the negative 6, if I look on my chart, it's right here. That value can be represented with a micro, so that's 54 microliters. Number 5 is 93. That's 10 to the negative 9, which is right here. That value can be replaced with a nano, the prefix nano, so that would be 93 nanometers. And the last one, 1.07 times 10 to the negative 12. 10 to the negative 12, that value can be replaced with a prefix of pico, so that's 1.07 picograms. In these problems, I'd like for you to rewrite the number with the correct prefix based on the engineering notation. And when you do so, round it to 3 significant figures. So you need to remember how to find significant figures, how to round, how to find engineering notation, and then the correct prefix. So in the first one, if we look here, we have a decimal in front of the 9. And in order to get that into engineering notation, remember I need to move the decimal by 3 places at a time so that I end up with 1, 2, or 3 digits in front of the decimal. So if it's here, I'm going to move it 1, 2, 3, and then I will have 3 digits in front of the decimal. I also need to round it to 3 significant digits. The 5 is my 3rd digit. After the 5 is a 6, which is greater than 5, so I'm going to round up. So I'm going to have 906, round this 5 up to 6, times 10, and I've moved, remember, the decimal place 3 places. It's going to be negative because I moved the decimal from the left to the right, which makes sense because I want to multiply 906 by a small number, a number less than 1, in order to get a number over here that's less than 1. And then I go to my chart and I can see that 10 to the negative 3 can be represented with milli, so this can be written as 906 millimeters. And remember to keep a space between the number and the units, but not between the prefix and the units. So pause the video and see if you can do the rest of the 5 problems. So here are the answers that you should have gotten. If you did not get these answers, then go back and either review this video, or perhaps you need to review engineering notation, rounding, significant figures. Once you are comfortable with this, then I'd like for you to go to the practice quizzes on Blackboard and do the practice quiz on units and prefixes.